Hello and welcome. I'm Dr. Rebette Jones, and today I'm going to present the Harnessing the Speed and Accuracy of Machine Learning to Advance Cybersecurity. As digital devices and online services continue to expand in our daily lives, cybersecurity threats have become more frequent and sophisticated. So the increase of connectivity comes in a rise of cybersecurity. Malware and malicious software designed to damage, disrupt, or even gain unauthorized access to computer systems. It is a major concern for individual and an organization. Detecting malware early is crucial to prevent potential damage and data loss. However, with the increasing volume and complexity of malware, traditional signature-based detection methods have become less effective. Recent advancement in machine learning technique have provided a promising solution. And that's for detecting malware. And the ML algorithm can analyze large data sets and detect patterns difficult for humans to identify. In addition, ML algorithms can learn from past experience and improve their accuracy over time, making them a much more powerful tool for malware detection. We present a comprehensive review of the current state of ML based on the malware detection. We can also explore the ML technique, including supervised and unsupervised learning, deep learning, and also reinforcement learning and their application around malware detection. We also discuss the challenges and the limitation of ML based on malware detection, such as potential for adversary attacks and in the need of large amount of labeled data. Now, the next slide is going to look at the graph. This is a comprehensive review of the ML-based data. So if it reads in the bottom, the graph depicts the major impacts of cybersecurity attacks on the organization in 2021. Besides work interruption, cyber attacks can also lead to loss of customer. Okay. Additional costs for external services address the issue at 41%. Theft of intellectual property, 20%. Sustained productivity impairment and business shutdown. Okay. So the insight into the future of direction of ML is based on malware detection, including integrating multiple ML algorithms and using explainable AI technique to enhance the interoperable of ML based on detection system. In the presentation, we will kind of talk about the research highlight and the potential ML-based techniques to significantly improve the speed and accuracy of malware detection, and also to contribute on the ongoing effort to enhance. Okay. So this is the malware-based analysis. If you see the training phase, we'll talk about that later. Malicious data, benign data, the training, predictive model. You see the testing phase, unknown data, processing by predictive model, and then also you're going to see the malware benign model decision. Okay. So the next slide would different. We would talk about the main ML or algorithm for addressing the specific cybersecurity issue. So we're going to also talk about the reinforcement learning. So the reinforcement learning is an ML algorithm that can learn through a trial and error. Okay, so in malware detection, reinforcement learning algorithm can learn to make decisions now based on feedback from the environment. For example, researchers have used reinforcement learning to detect malware by training agents to classify a file based on their behavior. The agent receive feedback and in form of reward or correct classification and penalties in the correct classification. Okay. The supervised learning is a type of machine learning algorithm that learns from label data. Okay, the content of malware detection supervised learning algorithm utilize label data to identify patterns that differentiate between benign and malicious software. Supervised learning technique commonly is used in malware detection such as decision tree, support vector machines, and random forests. Okay, so on this slide, we talk about the application of decision tree and the SVMS, which is the malware detection. So the decision tree algorithm can be used to identify malicious file and specific features such as the file size and IP and the presence of the certain strings. Okay, and also the decision tree provide intuitive and interoperable ways of classifying the malware. Not only that, the SMF, the FMS, VMS have been employed to classify malware-based features like the presence of the specific APIs or maybe a system call, we call it. SVMs offer robust classification capability. It can handle complex decision boundaries. Okay. So the unsupervised learning is a powerful approach in malware detection and it does not require label data, which can be scarce and maybe sometimes consuming to obtain. By analyzing the structure and behavior of malware sample, unsupervised learning algorithm can identify patterns and group similarity sample together. Okay. Clustering algorithms like k-means and hierarchical clustering are commonly employed to group malware sample. It's also based on its behavior and structure similarity around there. Okay, this group helps identify common characteristics among malware sample, which may aid in understanding their nature and in developing effective countermeasures. Okay. All right, so let's talk about deep learning. So deep learning technique is a particular effective in detecting complex and sophisticated malware that can exhibit subtle patterns of variations. Okay, convolutional neural network, which is CNN, okay, are well suitable for analyzing structured data such as opcode or sequence extracted from binary files to identify malware. Recurrent neural network, which is called an RNNs, are commonly used to capture temporal dependency, make them suitable for detecting malware based on temporal pattern or API calls. Okay, so deep learning model requires a large amount of label training data to achieve optimal performance, but they can offer high accuracy and robustness in malware detection tasks. Okay. Okay. So reinforcement learning in malware. So the reinforcement learning is a promising approach in malware detection as it is adapt and improve its decision making based on feedback from the environment. Researchers had to employ reinforcement learning to detect malware by training the agent to classify files or their behavior. Okay, so the agent received feedback in the form of reward or correct classification, penalty for incorrect classification, allowed them to learn and refine their classification ability. Reinforcement learning offers the potential to create adaptive and proactive malware detection system that can continually improve and adapt new threats. Okay, so that's reinforcement. So, increasing scales, frequency, and the impact of cybersecurity threat pose significant challenge to individual, organization, and government. Factors like cybercrime as a service or model, DevOps deployed by attackers, and classification of computer service have amplified cyber threats. Cyber criminals, financial resources, or coordinated efforts enable them to invest in research and develop to create more advanced attack models. So the market data shows a clear need for intelligent solution to combat these growing cybersecurity threats. Okay. So, like we explained earlier, machine learning offers a promising approach to tackle these ever-evolving nature of cybersecurity threats. So ML algorithms can analyze large volume of data, detect patterns, and identify anomalies, enable proactive threats and detection and response. The REA as a methodology is used to systematically review and critically appraise existing research on the role of ML in addressing cybersecurity threats. Through the evaluation of literature from various e-database, evidence is gathered to understand the potential application or the ML, or we call it machine language in cybersecurity. Okay? So the extensive use of internet-enabled system and network has increased the need of robust security strategy. Conventional technique provides protection but struggles against evolving sophisticated cyber threats. AI and machine learning solutions are imperative to fortify cybersecurity by adapting new attack methodology. ML enables the automation of routine tasks like freeing up administrative time and enhancing their situational awareness. The proprietary nature of business operation and the invariant objective of computer system hinders standardization in cybersecurity system. So keeping pace with the volume of security alert is significant. It's a significant challenge. It's very challenging. But machine learning models can help improve efficiency over time. Advancement in machine learning will contribute to the training of new cybersecurity experts and addressing existing challenges incrementally. Okay? So, future direction in machine learning for cybersecurity. Okay, so the machine learning model will continue to evolve and improve to meet the challenges posed by cyber threats. Incremental advancement will contribute to the standardization of cybersecurity system, overcome proprietary nature of the business operation. Now, we say that automation will be enhanced as machine learning becomes more sophisticated, reducing the manual work of cybersecurity administrators. Clarifying goals and objectives and automated process were crucial to align the specific needs of computer system network. Machine learning will aid in addressing difficulty in managing sheer volume alert, the security alert. And the future of cybersecurity relies on advancement in machine learning, will shape the training and the expertise of cybersecurity professionals. Thank you. That is in my presentation.